So jumping right in, this last page deals with what you need to know from Chapter 6. And all of these questions are based off this scenario. It says current IQ tests are normally distributed. And that's a key indicator that this is from Chapter 6. When we're dealing with that normal distribution. The mean is 100, and the standard deviation is 15 IQ points. Part A asks what z-score corresponds to an IQ of 140, and what does this mean in context? Well, z-scores are something like we calculated back in Chapter 3. Z-score is equal to x, your observation, minus mu, your mean, divided by sigma, your standard deviation. So I'd say 140 minus 100, that's 40. And 40 divided by 15, that is 2.67. So this means a person with an IQ of 140 is 2.67 standard deviations above the average. We already know they're above the average by 40 points, but they're 2.67 standard deviations above the average, which also means that person would be an outlier. Their IQ is so high, it's extremely high, be classified as unusual or an outlier. Once the z-score is 2 or above, it's an outlier. Part B is where we see our Chapter 6 problems come into play. It says, what is the probability a randomly selected person has an IQ below 140? So whenever I'm dealing with a probability from the normal distribution, not with dice, not with a two-way table, but probability in normal distribution, that indicates that I want to use normal CDF on my calculator. To give you a quick sketch of this, it's not the standard normal curve, it's just a normal distribution. I would have my mean of 100 in the middle. I'm looking at the marker of 140, and I want 140 and below. This is my shaded area. So I'm shading a lot of the curve. My lower bound, my left bound, this goes all the way down the curve to negative infinity. My upper bound, the shading stops at 140. My mean is 100. My standard deviation is 15. And you can see I've got the values you enter right here. It's going to be normal CDF negative E99. Remember, to get to normal CDF, you hit second vars. It's number 2. There's no negative infinity on your calculator. The lowest number it can take is negative 10 to the 99th, so it'd be negative. That E comes from hitting second and comma 99. Right bound would be 140, comma, our mean of 100, comma, our standard deviation of 15. To 4 places we get 0.9962 due to some rounding. So we've shaded a lot of the curve. We've shaded 99.62%. This tells me that 99.62% of people have an IQ below 140. C is similar. What is the probability a randomly selected person has an IQ above 90? For my sketch, I'll have a very similar normal curve. 90 is just down here below 100. I want this probability above here, so I want the area underneath the curve. All of these areas are programmed in under normal CDF. So it'd be normal CDF, the left bound, the lower bound is 90. The right bound is positive infinity or positive E99, 115 for our mean and standard deviation. Gives us 0.7475, so we have 74.75%. Part D, probability a randomly selected person has an IQ between 95 and 125. Again, the key word that tells me to use normal CDF is the probability. Here's 100, right in the middle, 95 below that, 125 above it. And those are my lower and upper bounds. I don't go all the way down to negative infinity. I don't go all the way up to positive infinity. So it's 95, 125, 115. Be 0.5828. Final 2 questions. Go the opposite direction as we saw in Chapter 6. E says, what IQ corresponds to the 75th percentile of IQ scores? This is where it's very helpful to sketch out what you've got to see what you need to do. I know IQ scores are normally distributed with mean of 100 in the middle. I want to know what IQ score corresponds with the 75th percentile. So I want to know a value down here. The 75th percentile is going to be marked somewhere right here. I want to know, what is this value? The percentile tells me the percentage to the left. I should have 75% of my observations below this value, which by the complement means I have 25% above that value. What IQ separates the bottom 75% from the top 25%? Whenever you have your percentages, that's when you go to inverse norm. Go to second, vars number 3. There are only 3 items to enter. It's always the left-hand percentage or the percentile as a decimal. So it's going to lead with 0.75. Then just like normal CDF, it ends with the mean, which is 100, the standard deviation, which is 15. That was given top of the page. So we get 110.1, and this should really be a 2 when I round to 2 places. So if a person has an IQ of 110 or so, they have an IQ higher than 75% of people, but lower than 25% of people. Final question. What IQ score corresponds to the 10th percentile of IQ scores? Very similar problem. This time I got the 10th percentile, so that means 10% is on the left. This is 10%. This is 90%, but we always use the left-hand side. So it'd be inverse norm, 0.10, 115. This would be 80.78.